What up, y'all? It's your boy Pacho coming at you live with another calc video.
It's John 117.
Wake up, Mr. West.
It's
Mr.
Master Pacho.
I'll have to edit all that.
I'm being held hostage.
Help.
Where's your armor?
Pachapito. Help.
Where's your armor?
So, summary of curve sketching. So,
Is that your
you're going to see this. You're going to see this on the AP exam when you do not have a calculator. So you're going to have to be able to actually figure out what a graph of this is going to look like, given you're going to know the minimum, maximum, you're going to know points of inflection, you know that you're going to have asymptotes. So we're going to do a whole bunch of stuff here. Okay, it's a lot of algebra basically though. So determine the domain and range of a function. Okay, yeah, so that's the first, figuring out. Okay, that's like asymptotes, right? Finding your asymptotes, so when I'm sketching it, that's important. Determine the intercepts, asymptotes, summaries, symmetry of the graph. Locate x values for my f prime x or f double prime x, either zeros or do not exist. Use the result to determine relative extremia and points of inflection. In these guidelines, note the importance of algebra as well as calculus for showing those equations. So your function equals 0, your first derivative equals 0. So when your first derivative equals 0, what does that give you?
It gives you the where the slope is. Max or min?
Min or max, right? Okay, min or max. And second derivative equals 0.
The slope.
No.
Oh wait, no. That's the concavity.
That's for the concavity, right?
I want to say cavity.
So, but when it's equal to 0, what does that give you? So if we go back to the notes from yesterday, so if it was positive, it'd be concave up. If it's negative, it would be concave down. But if it was equal to 0, that is my...
Oh, that's the point of inflection?
There we go, point of inflection, that's what I'm looking for. So then we have point of inflection there. Okay, analyze, sketch of the graph right here. So first thing.
We get at the bottom? Oh wait.
Huh?
Never mind, sorry.
Okay. What would I do? You said first thing for the bottom. What about it?
F.
You said F the bottom. Why F the bottom?
Because these stuff cancel.
It's going to give you what?
The zeros.
It's going to give you zeros for what?
Oh, asymptotes.
Asymptotes. Thank you. That's what I'm looking for. So we have asymptotes where?
Positive and negative.
X equals positive and negative 2.
So from this one right here, I have asymptotes at plus or minus 2. Okay, so that's going to help me out. Any other issues I might have?
No.
Not from that. Now, okay, algebra. Algebra, right here. So, right here. Same degree, right?
Yeah.
Okay, same degree. So that's important to pay attention. Because if the top was 1 degree higher, what would I have?
It'd be,
Positive infinity?
yeah. I can't remember.
No, that's a limit. That's a limit.
Oh,
going.
wait. Wait.
I was thinking.
Think of algebra though.
Okay, if the what? If the degree?
If the degree of the top is bigger, what's it give me?
Oh.
What type of asymptote?
Vertical?
No,
Horizontal.
It's the
Diagonal.
It's a diagonal. There's a diagonal there.
What?
Yeah, you would have a diagonal.
You gotta teach me this.
I thought if it was like
What's
the
the next
same.
No, wait, next one.
Okay, so let's take a look. So let's go ahead and find the first derivative.
Oh, a slant asymptote. Oh, wait.
Yep.
Oh.
So f prime of x. So I'm gonna have, what's that gonna give me?
F prime?
F prime of x.
The whole thing, or
Okay, starting off with the top.
okay, we have.
Quotient. Wait, that's constant?
So we have
4x times x squared minus 4 minus 2x, right?
Yeah.
Yes. Times 2x squared minus 18. Yes?
we just distribute.
I have to distribute, right?
Yeah. Okay.
I have to distribute. I'm going to have to distribute anyway, so might as well distribute at first. Okay.
Yeah, I thought you would multiply to the 2x.
I will, but it's fine now. So I just want to show that the 2x is the derivative of the bottom, just like the 4x was the derivative of the top.
Why can't I write small?
All this is going to be over
X squared minus 4.
x squared minus 4 squared. Clean it up.
Take out.
Take
Take
out
out a 4x.
Yeah. Wait.
Yeah.
Yeah.
I could.
Yeah.
If I take out a 4x, I'm going to have x squared minus 4 minus
2x squared.
nope, it's just going to be x squared, right? Because I took out that 2 that I put in earlier.
Minus, well, yeah, that's why I was wondering why you distributed over there.
X squared plus
Plus 9.
9. Okay, what's going to happen to these things right here?
They cancel.
Okay, so those going to cancel out, so I'm going to be left with what?
5.
5 times this, right? So it's going to be 20x all over x squared minus 4 squared. So this is my first derivative, right?
Like this. Not even everything, man. I'm already out of space.
I'm a waste of space.
Don't say that.
Kidding.
You're a waste of atoms.
Do you need more scratch paper? I have more scratch
No, I
paper.
have paper.
You got paper?
Yeah.
I have a pile back there.
What the heck? Oh, that's the prime
Oh,
symbol.
man.
Yeah, that's a prime. I'm sorry.
Why
My
did he leave today? I got him this white paper he wanted.
P one.
Jerk.
Why can't it be black paper?
P one.
Don't have me, he wanted white.
It's the prime.
Don't you mean printer paper?
Is that better?
What's the problem with it?
Okay, so let's go with second derivative. Listen up, please. Hey,
28. Oh, wait, no. 20.
second derivative. So
28 times x squared minus 4 squared minus. Oh, you're writing it back. Okay.
it's going to be
Minus
20?
20 or 20x times. I forgot.
20x times 2 quantity x squared minus 4, right? Times
To the third power.
the derivative. What's the derivative of the inside?
2x.
2x, right?
Yeah. Shouldn't it be to the third power?
Why would it
Oh,
be
wait,
2?
never mind. No, I forgot. I was thinking of it.
Okay, so yeah, don't forget I am subtracting, right? Okay, so I did chain rule off of this, and then derivative outside would be 2 minus 1, got that, right?
Plus 4
And then the derivative inside is 2x. So all this is going to be over
over
x squared minus 4 to the
fourth.
4th power. Okay.
Oh, we could take it at x squared minus 4.
I'm going to take out a little bit more than that. I'm going to take out a 20 and an x squared minus 4, right?
Wait, 20x squared?
20 and then an x squared minus 4.
Oh, okay.
There's not an extra x right here.
I didn't hear the full complete.
Sorry. So that's going to be right there. And so I'm going to be left with x squared minus 4, right?
Yeah.
And since I took out this 20 over here, right?
Yeah.
Took out that 20, I still have an x and I have another x over here. So that's going to give me,
Yeah. That's 40, so.
it's going to be, look, I took out 20.
So
So I'm going to have 4x
X
squared. Okay? So that's going to be negative, right?
Yeah. Squared times x squared minus 4.
Right?
Yeah.
X squared, so that's from my first one right here. So x squared minus 4 from there. And then what's left over here, because I took out the x squared minus 4 to bring out here.
4.
And so just 4x squared because I had the x from the 20.
All over x squared minus 4 to the third.
Nah, still to the 4th.
Still to the 4th because I have not done anything with it yet, right?
I canceled it before.
Oh, you already canceled it?
Yeah.
No worries. All right, cancel out that one, so I'm still a 3 here.
20 quantity
Okay, so clean up the inside. What am I going to have?
x squared. Oh, negative
Negative
4.
3x squared. Negative 3 squared.
Negative 3x squared minus 4, right?
Oh, yeah.
Okay. So if I want to put that negative out front, right? So negative 20,
I know, bro. That's what I said.
negative 20, and I'm left with what?
Negative 3x
I already gotta have
squared.
this paper.
3x squared.
Minus 4. Over x squared minus 4 to the third.
I took out the negative and I put it in front of the 20.
Negative, oh, that's what, oh, my bad.
Because I'm just trying to clean this up right over here.
Yeah, my bad.
So I took the negative out front to clean this up because I hate having a negative in front of my x squared, because the negative in front of the leading coefficient, it makes it difficult to factor if I need to. And all this is over.
X squared minus 4 cubed. I see.
Okay.
He's a blind man.
So you have those written down?
Yes, sir.
Okay. I'm gonna go to the next page and I'm gonna bring over my derivatives.
Wow, he's pretty down.
I'm still. Well, you're right edge.
Oh, here it is, right here.
I need lessons on
There it is.
race.
Okay. So f of x was 2x squared minus 9
Mhm.
over,
X squared minus 4.
okay, f prime of x,
Negative 20. Negative 20.
Negative 20?
Yeah, because he factored out the negative.
no,
No, this
first,
was
first,
Oh wait, that's the second derivative. I'm
just put a
retarded.
plus.
I want first derivative, right?
20x over
20x
x squared.
Minus 4 squared.
Haha, testing you guys.
This is squared here, right?
Yeah.
Okay, f double prime.
Negative 20. Quantity 3x squared plus 4. All over x squared minus 4 to the cube.
There we go.
What is- I totally forgot.
So I have my function, I have my asymptotes, right? I've asked, yes.
If you kept taking the derivative, would the power on the bottom keep going up by 1?
Yeah, it should.
X which means
It should, because I'm still factoring
because you bring it up to the
this,
top.
because I keep having this. And as you bring it up to the top, I could factor it in both. If there was a single, then it wouldn't, like right here. Right when I did my chain rule off of the x squared right here, right? I was able to have that one on the top and two of them there. So when I have my g and my g prime, should both have a x squared minus 4 in it because of the chain rule here. Okay, does that make sense? So yes, I should have it going if I keep going in powers of that. Okay, so now, now I have everything I need, I think. Everything I need, I think. So let's take a look. So if I'm looking at my graph,
The original or the derivative?
graph of the function, because I'm going to sketch a graph.
Oh yeah.
Sketch a graph given. Where's my thing at? Here it is. So sketch a graph, analyze and sketch a graph of this. Okay, this is without a calculator, so we know we have asymptotes at plus and minus 2.
They're vertical, right?
Okay, asymptotes at plus or minus 2. I'm going to put those in right now. So, there we go. I have asymptotes there. So, I got that much. Okay, that's a start.
Okay.
Now let's use my first derivative.
To find the min, the max, by the extreme.
Yep.
Okay, set it equal to 0.
So set this equal to 0.
X equals 0.
The bottom goes away.
Set it equal to 0. So I only have one place, right?
X equals 0.
At x equals 0. So this is, yes? You agree?
Two thumbs up from this guy.
Okay, so we get an x equals 0 here. Okay, what else do we have?
At the first derivative? Or the
Okay,
second one?
and from the first derivative, okay, we got that.
No.
Now,
Oh, wait.
let's take a look at the function. Can I do the same thing for the function?
Oh yeah.
What's it going to do for the function
The
for me?
y-intercept?
It's going to be the x-intercept.
Oh wait, yeah.
It's going to be the x-intercept.
forgot
So
how
if I
red the
set the
graph was.
function equal to 0,
Forgot how really the graph
that's going to be where it's going to cross the x-axis, right?
was. Right.
And this says what? So, throw that out, right?
That's
Set it
also-
equal to 0.
X plus or minus?
X plus, oh wait.
X
Plus or minus?
3, oh yeah.
plus or minus 3. So it's going to cross the x-axis at plus or minus 3. So now, right here,
3,
I'm going to have a point here.
3.
And here, I have a point here.
Did you grab each?
Okay, so now, let's take a look.
I'm confused.
So since I only have one place with my first derivative is equal to 0, that means that I only have one place that I'm going to have a min or a max. So it's going to be somewhere in the middle. It's either going to be a min or max.
Is it gonna be like this?
Okay, let's see what I get out of it. So let's plug my first derivative into my original function.
So we have -4.
So plug the first derivative into the original function and you get
Negative 18 on top.
Negative 18 over negative 4.
f of 0 is, what is it?
Negative
18 over 4. Two
So
negative
it's
four.
negative 18 over negative 4, which is
18 over 4.
18 over 4, which reduces to
9 over 2.
9 over 2.
Hopefully nerd.
Okay, so at 9 over 2, which is 4.5, I have a point right here. That's going to be either a min or a max. So this one's going to be my
Whoa, what's going on?
9 over 2. Or 4.5. So I have my point right there. So it's either a min or max. So I have a lot of things now. Let's go down to the second derivative. Okay, given second derivative. So if I set my second derivative equal to 0, what does that tell me?
Is that not to scale?
No, it's not to scale. Thank you.
Points of inflection.
Oh, 'cause
Point to inflection, right?
So it's going to be plus or minus the red.
Okay, so let's take a look. So if I set this one equals 0, 0 equals, I could throw out the denominator, so it's negative 20,
times 4.
3x squared plus 4, throw out the negative 20, right? So it's going to be negative 4 over 3.
So the plus or minus the square root.
4/3.
So, can I have that?
Imaginary number.
Imaginary, so what does that tell me?
It's
No point of it. Oh, it's like it's what it's like.
Yeah, it's not going to change concavity, is it?
Like whoop.
It's not going to change concavity,
Ooh, what is that? I don't like this.
right?
part,
It's not going to change concavity from that.
Mm.
Okay, so since it's not changing concavity, what else do I get from this?
That it's negative, so it'll go
You
down.
can.
Oh yeah.
It's what?
It's negative.
Okay, so right here, I know it's going to end up becoming, so if I plug in a negative 3, because that's one side of my asymptote, right? If I plug in negative 3 into my second derivative, which would be right here, so negative 3, so f double prime of negative 3 is,
27 plus 4 is 31.
so negative, so this is going to be positive, so the bottom's a positive,
The top is a negative.
Yeah.
top is going to be a negative, so the whole thing is
Negative.
negative. So what does that tell me?
It's
We're going down.
It's down.
Concave down. So that's going to be concave down. So this piece is concave down. Okay, what do you think is going to happen at my positive 3?
Concave.
Concave up.
Let's see. So f double prime of positive 3.
So we have.
The top
it's
is
still
negative.
The top.
Top is still going to be negative, and the bottom is going to be
Negative.
Positive.
Oh, positive.
So it's
positive, so it's negative, so that tells me,
Sit
Goes
down.
down as well.
okay, they're both the same. What about the middle? Let's plug in 0.
Down. 0. 0.
0 over 0, is it not?
Negative over undefined.
Wait, it's 4.
Negative.
So you're going to say that's undefined?
I'm
No.
just saying
No.
Negative.
It's positive.
It's a negative.
It's a positive.
No, the
It's a
positive.
negative
It's positive.
and a negative
Positive.
positive.
So,
So that means that's going to be concave
up.
up. So it's concave up. So now I know concavity, right?
Yeah.
I know concavity. So now is there anything else I need to try and think about before I start sketching some stuff?
Wait.
Think about the function.
What about the slant?
Did this one have a slant asymptote?
This
No.
one did, I forgot.
It's only if the top is 1 degree higher, right?
Oh,
Mhm.
yeah, never mind.
Oh, that was a high pop. Oh, wait, oh, like got confused on this. What the heck?
Okay, that was a slant asymptote. What about,
And
how do I have a horizontal asymptote?
Oh, that's the point of inflection, right? No. Yeah.
Horizontal is.
When,
Is
oh,
it
wait,
with
is
the-
it when it's equal to 0? Something's equal to 0.
Is it
Is it
Okay, it has to do with the degrees.
F double prime? Or?
No, has to do with the degrees.
Oh, wait, hold on, time out.
Is there a way to look it up?
Is there old notes?
Isn't it?
No, I don't have old notes on this because this is algebra.
Yeah, I can't remember.
No.
Isn't it?
I said I thought it was on the old
If
notes.
like the top and bottom have the same degrees and you just look at the coefficient.
Excellent,
just-
there it
oh,
is,
I
right?
forgot about that.
So,
Same.
very good. So, what is my horizontal asymptote?
2.
It's going to be 2 because I'm looking, I have the same degrees, right?
Yeah.
So, it's looking at these numbers right here. Looking at those numbers, the coefficients, so I have a horizontal asymptote at 2. So it's going to be right here at 2. I draw a dotted line this way. So there we go. So now that I have all my asymptotes, I have all my concavity, okay, I have everything there, right? I think so. So if it's going to an asymptote, what do you think is going to happen?
It's gonna
It's getting close to it and it just keeps going up, right?
forever.
So we've already stated,
So that's a min.
we already stated that this one is going to be a min for this one right here, right?
Oh, yeah. Oh.
This is going to be a min because look,
Yes,
look
sir.
at my asymptotes actually boxing it in. So I'm going to have
He's playing some hardcore defense.
right here, like this. Now the other side over here I'm going to have,
Like that.
and same thing over here.
Horseshoes. Oh, what the heck is that?
I kind of missed my 3 here, but hey, I'll make my 3 bigger. There we go. It's a bigger
Yeah,
dot.
Chef Curry.
Sweet.
Okay.
I'm agree.
Wait,
Hmm.
if it's over at the F
Low-key confusing.
prime equals 3, or F prime of 3.
For
looks like
real.
it's increasing.
That's what it is.
F prime of 3.
Yeah.
I gotta
3?
Look, instead of writing
Well,
something.
if it concaves down because it's negative.
Is concaving, but all of this is, it's not going to change concavity. It all has the same concavity of down.
But it looks like it's increasing.
That's just my horrible drawing skills.
Eventually, isn't it gonna start going down though?
What do you mean?
Even little by little, if it keeps going this way. No?
Yeah, it's eventually going to here, but it's never going to hit 0. It's never going to hit 0,
two?
and it's never going to.
You mean 2?
Oh, I'm sorry, you're 2. You're right. So my slope is never going to hit 0. That's what I was referring to. So my slope is going to get approaching 0.
It's
right?
close, but-
Yeah, it's going to get close, but it's
Yeah,
still going to
I'll
keep
see
getting closer because it keeps increasing to my asymptote. Remember? It's getting close, but it's never going to touch it. So it's gradually growing and growing and growing. So it's increasing slowly, even as I go on to infinity, but it's increasing slowly. It's just very small amounts.
It's never.
Yeah.
How does no
But,
people
like-
count it?
I wouldn't count.
Solving
Can you just
it,
keep on going
solving
forever?
it algebraically, it's negative. So then, I don't know, it's just doesn't.
Quick Photoshop.
Do what?
Just look at it. It's okay, so like f prime of 3 is negative right there.
F prime of
F
3,
double prime of 3, my bad.
F double prime of 3 is negative.
Yeah.
So
But,
that's
like,
concave
the
down.
graph looks like it's increasing instead
You're looking at the wrong one, Pacho. You put it at F double prime at -3.
Oh, F prime of 3.
Yeah.
of.
Oh,
Yeah, but look
okay.
at it, isn't it kind of like it's increasing?
Like.
Okay, no. Or are you talking about the slope?
It's increasing at a decreasing rate.
But that's.
Yes, okay, that would be a slope. Now, which derivative do I use for the slope?
First prime.
First derivative.
This is. Double.
Second one tests concavity. First one tests my slope. Okay, so let's try it right here. Let's try 3 into my first derivative. So if I do f
So 60
prime of 3,
60 over 25?
60 over 25? What'd you
That's-
say?
That's
Yeah.
positive though.
Okay, so this is a positive number, right? So I have a positive slope.
Just finding if it's positive or negative.
Right? Is that what you're talking about? Okay, then if I check the other side, so f prime of -3,
2.4? Damn, crazy.
Be a negative.
Negative.
okay, it's going to give me a negative. Does that make more sense now?
Yeah.
Okay, because first derivative is my slopes, second derivative is concavities, or points of inflection,
What's third?
is the jerk.
Jerk.
Oh, that's
Well,
not so good.
we need that for calculus.
No.
Or not till we get to BC.
Okay. They can ask you for the up to the fourth derivative. I've seen up to the fourth derivative, and it's not something that actually this isn't even that nasty.
That's what I give up.
Okay.
Or is it just like find the fourth derivative?
Yeah,
and
and
it's just like annoying.
like on that last test,
Yeah, all that.
where I said find the third derivative, first, second, third,
That's nasty.
and it was just like a
Quotient?
quadratic or
It was no.
no?
It was no. You made us do quotient rule inside product inside. It was poop.
Okay.
It was.
There was another one that it would start off with like an x to the fourth or something like that,
Yeah.
and you just had to keep taking the derivative of each, right?
Not bad. Those ones.
Oh,
No, that's cool but annoying.
Like
Alright.
polynomial.
Makes sense?
Yeah.
Are we okay here now?
Yes, sir.
If it was just a basic polynomial, I would have.
Those are easy peasy.
All right. So sketching rational function.
Oh,
So-
dot has slant asymptote.
Slant asymptote. What I know, it's a slant asymptote.
Because it's the.
The-
it's
Oh,
the
because
degree at the top is
the
higher
x
than the
squared and then
degree
there's
at
an
the
x on the
bottom.
bottom.
Oh, and it says
Yeah.
right there too.
So, all right. So let's take a look at this one right here.
I have to circle that.
X squared.
No, I did it.
Okay. So let's take a look. So first thing I should know, asymptote. What's this one? Let's deal with this one first.
Two.
Positive 2, actually.
So asymptote. I don't know why I put x equals. I was supposed to write asymptote.
We understand.
Okay, let's take my first derivative. First derivative. So f prime of x is 2x minus 2
times
over.
what?
Oh, I'm sorry. I don't know what I'm doing.
Times. You're thinking of L'Hopital.
I don't know what I was thinking. All right, so 2x minus 2 quantity x minus 2 minus 1,
One.
right, times
X squared plus minus 2x plus 4.
all this is going to be over.
X minus 2 squared.
Even if I try.
Is it quiet? That's Brian.
All right, can I factor the top?
Yes.
Yeah, you could try.
Well,
You could try, can we?
x plus
X minus
x
2.
plus.
You know
Wait,
what?
no.
I'm not trying to do that.
X
No?
plus 2 and x minus 1. Oh no, wait. Huh? Let me say that, bro.
It's only 2 and 2 or
1 and 4.
1 and 4. So can I get it? No, I can't. So I just wanted you guys to pay close attention because if I can, what would that do to help me out?
You can factor something.
I was hoping I could cancel out the denominator somehow, right?
Yeah, like the x minus 2.
Yeah, that would have been nice, right?
Damn.
Okay, just want to double check that one. All right, so clean up.
Would that change?
Can we make the 4 negative just to help us out?
Can we make the 4 negative just because?
Yeah.
Nah. All right, so
You have to make.
go ahead and FOIL this one.
It's you get 2x squared minus 6x plus 4.
Minus 6x plus 4 minus x squared plus 2x minus 4.
Oops.
All over.
I missed that part. I got it.
You got the second chapter.
Did you get it or
No, like.
did I make a mistake on that one?
You just missed the second part of the problem.
Yeah. I had negative x squared minus 2x plus 1.
Oh, forgot to distribute the negative.
Why is there such a big gap between the 4 and the minus x squared?
Okay, so right here, clean up. What do we get?
4 is out.
I have x squared, right? I have 1x squared. What else do I have?
Minus 4.
Minus what?
4 plus 0
Okay, over.
I
x
think there
minus
should
2
be
squared.
a cube.
Plus 0.
Isn't there like a 2?
There's not.
There's
Oh, that'd be 4. 2x times x.
There's 2x squared.
2x squared.
Oh, oops. What the?
Are we okay? All right, so this is my first derivative, right?
Punch it.
Yeah.
I have a question. So like, if you were able to factor the like an x minus 2 from the top, What difference would it make
If I had an x minus 2 in the top, I would account for it having a hole. Remember, it's not going to be an asymptote. If I factor it out, remember we were doing the limits?
Yeah.
Ah.
And I was able to factor it out. It was a removable discontinuity. Do you remember that now?
Those were scrumptious.
So we could remove it, and then we cancel out, and make my derivative a whole lot easier, right? Because I would have a lot less from my derivative.
Gosh, dang, get the nerds back.
Okay. Alright, so now I have this. So there's my first derivative. Let's go to second. So second derivative. So f double prime of x is going to be 2x minus 4, right? Yes?
Yes, times
Okay, times
2.
x squared minus 2 squared minus my
Wait, what?
2 quantity x minus 2.
Wait, Pancho, wait. I mean,
What? Did I lose you? What's wrong?
I'm trying to catch up.
I think no, I thought you said there was a 2 in front. Never mind.
Okay, so I just did the chain rule for the bottom right now. And the derivative of the inside is just going to be 1, right?
So
Nothing changed
For
for the
the
question.
wait for the first part when you did okay over 1 x squared minus how do you get x squared?
Oh, you're right, you're right. Thank you. Thank you.
Damn. So then-
I don't know, I guess I was already, I don't know what I was thinking of. I can't make an excuse for making a mistake. Sorry.
you can't.
Just say you just like.
So, I'll give away candy because I make mistakes. Here you go.
Can I get one?
No.
Corrected me yesterday.
Huh? I threw food at you. It just happened to be cheese. Alright, so,
She a jerk.
and so there's this one right here. I did the derivative of the bottom
Yeah.
times the top,
X squared.
right?
I think that's true.
X squared minus 4x,
The non-part.
right? The non-derivative. So I took the derivative of the bottom times the top. All this is going to be over
X minus 2 to the 4th.
Cannot write stuff. I tried.
And-
You can factor out a X minus 2.
x minus 2. That's why I left it like this. So I'm going to have an x minus 2, right? X minus 2. And I'm going to be left with
2x minus 4.
2x minus 4 times
X minus 2. Minus.
minus. So if I took that out,
2x
right?
minus 8x.
So minus 2x squared
Third.
plus 8x, right? Because I'm distributing this into that one over there. Because I factored out this one.
No plus 8.
And all this is going to be over my x minus 2 to the 4th power. So cancel out that. And I'm going to have to do some cleaning up here in a moment. So it's going to give me 2x squared. What's that going to be? Minus
4x.
4x.
It's minus 6x.
Oh, after you're done?
Yeah.
Okay. Then
There, 2x.
minus
2x.
Minus 4x.
4x. And then it's going to be plus 8. Right?
Every time.
It was always.
Minus 2x squared plus 8x. Keep my denominator.
Everything cancels but the 8.
And that was a 3.
If I did that right.
Okay. So I have a
2x squared.
negative 8x here
And a positive 8x over there.
and a positive 8x over here. I have a positive 2x
It's
squared and a negative 2x squared. So it's going to be
8 over
8 over.
x minus 2 cubed.
There we go.
Yay.
All right, so let's take a look. So I'm going to bring all these over to my
New page.
next page.
We got a couple minutes. We got 12 minutes, Pancho.
There we go. All right, so f of x was x squared.
No, I don't even remember. Where is it?
It's on the top.
F prime. Just single prime?
No, just F. I'm sorry, I put prime and I said
Prime
F.
minus
X squared.
2. Oh, wait. Wait, is this F prime?
No.
F, just
prime.
F.
X
Minus
squared
2x
plus 4.
X squared minus 2x plus 4 over.
x minus 2.
F prime.
Okay, so F prime of X.
X squared minus 4x.
All over.
All over X minus 2 squared. Yeah, double prime is equivalent to 8 over X minus 2 to the third.
Relatively simple, I guess.
There we go.
You should see my algebra, bro. I'm going to the side.
Okay, what else do we need to bring over?
Asymptote.
Asymptote. So asymptote. You know what? They say nothing's wrong with my smartboard, but
You see how straight those lines are?
I know, right? Okay.
You should let them do the straight lines.
My asymptote is going to be so. Let's say x equals 2 and y equals.
We always
The how do we do it?
Isn't it the
Yes. Top or the bottom? That's what 6 said earlier.
bottom.
top over the bottom?
Yeah. So what was the coefficients?
2.
It's just one.
It's 1, right? So it's 1x, right?
Oh yeah.
So 2.
So X.
Y equals X?
Oh, there is the 2 man.
Oh yeah.
Because my degree of my top is 1 degree higher than the bottom, right?
The original one?
Yes. So the asymptote on this function.
Oh.
That's cool. Who names that?
Okay. So, all right. So I have asymptotes now.
The slant asymptote.
Just 'cause it's like, if it's on the top, it's square.
So I have asymptotes. X equals 2.
You cancel out the square.
Right
You
there.
look at X up top.
Oh.
It's right there.
Huh?
You still confusing?
Yeah.
He is confusion.
Who is confusion?
He is Confucius.
Eddie.
Derek?
He's confused on the. What do you say?
Are we okay here?
Yeah.
Nah, he confused.
Let me
It's
get the
'cause-
slant.
The slant, I'm just,
Okay. The slant.
it's because it's the coefficient, right? But I'm just. Because
No,
they're
there's
different.
different rules depending on the powers.
Yeah, just because they're different powers.
Yeah, different rules because different powers.
Okay.
Okay. All right. So we have that. So, all right. It looks kind of wonky, right?
Yeah.
Okay. It's going to be kind of wonky through here because asymptotes usually hold them in place, right? They hold them in place, so they kind of like box them in. So let's go ahead and start solving some of this. So let's solve using my first derivative. What is my first derivative going to give me?
Your
The experiment.
Min or max?
Min or max, right? So what is this one going to give me? X equals
0 and plus or minus 2.
X equals 0 and
2. No, 4. Man.
because you're factoring out an X.
And then
You
X
could
equals
throw away
zero,
the
yeah.
you could throw away the bottom when you said it equals 0.
You look at X minus 4.
0 and 4.
I get 0 and 4, right? Because I factored out. Okay, so I know I have at 0 and 4. So at 0, I have
Man,
0 and at
I was gonna break that damn thing.
so 0 and 4, I have something. I know I have something in there.
Wait, does
Yes.
it touch it though?
I just marked it right here. It's not going to touch it, but I'm just marking my 0 on my x-axis.
Oh yeah, what does happen at that point?
Yeah.
Okay, we'll see in a moment. I know it's going to be a min or max, right?
No, but it's like on the.
That's
It's on the asymptote though.
No, that's just a value.
Okay, I'm just labeling these right now.
Because technically any X value is on the asymptote. Because those asymptotes go on forever.
Oh
Alright, you
yeah.
ready? You ready?
Oh, I'm done.
You ready?
I'm done. That's-
All right, so now, what do I do with these two values now?
You
What-
pl-
You plug
You
it
plug it
into
into
the
the
original.
Second derivative.
OG.
First,
OG.
plug it into the
Oh,
first.
Oh, first derivative.
Wait, so, what are we supposed to do?
Okay, so you'll see in a minute. We're gonna plug them into the second here momentarily also.
So 0 is 0.
What is like?
Plug into plug this one into my original function.
Okay.
Say second.
I heard.
Plug the
I was so confused. I was like, we just
plug the 0 into my original function. What do I get?
That's the
four.
You get negative 2, so it's negative.
4 over negative. Oh yeah, negative.
You
You get a negative value.
For
So
zero, you get negative.
it's gonna be. So you're saying that f of 0 is you
60 minus 8.
Negative 2.
4 over, so I get negative 2. Okay, so at 0, negative 2, I have a.
Minus 8.
Okay, right here I have some type of
That's why I
point.
get 6.
I have some type of point right there. Okay, so f of 4, I get what?
2.
6. Isn't it
Wait, why'd
6?
you go down?
You get
It's
6.
negative.
Ignore it.
I said it's
F of 0 is negative 2. That's negative 2, right? Okay,
Just ignore my stupid-
so 4. Do we plug in 4? What do we get?
Six.
6? Okay, she says 6. So,
She is.
you guys all agree?
Yes, sir.
Yeah, sure.
So would it hit the asymptote like
Plus 3.
on?
Okay, so it's gonna be, let me see, right here.
Would it be like similar like to 0?
Right here, so let's say I have a point here. I'm gonna have to creep that one up a little bit because it doesn't match. There.
I thought it would reflect, so I thought it would
Okay,
be
so
on that.
so those are my values. Okay, so what am I gonna do with those values now?
You give up.
Plug in the 0.
That's a second derivative.
Why? Why am I gonna plug in my second
To find the
derivative?
concavity.
It's gonna be concavity, right?
8 does
So
not
plug
equal
in 0, or yeah, plug in 0 into my second derivative.
8 does not equal 0.
F double prime of 0 is
Uh-oh.
Negative 2
Undif-
to the third.
Does not exist.
Wait, why?
I don't know.
Negative 2 to the third.
negative 2 to the third is negative 8. Negative.
1.
Negative 1.
Oh,
Negative
oh,
one.
he plugged in.
So it's a negative, right?
That's like 2 minus 1 over 2 minus 1.
So we get a negative, so that means it's gonna be concave.
Down.
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 Okay.
That's what they mean calculators.
This even my friend.
Next one is positive.
F double prime of 4.
It's positive.
Okay, 4, that's gonna give me 2, it's positive.
Positive.
So that's gonna be concave up. So now, if I'm doing this right, should look something like this now. And something like that.
Yes, Cristo.
Yay, man.
I'm pretty proud of my sketch.
Hopefully it's better than mine.
Oh, okay, I see what the 0 is.
An ATS and it's perfect.
I thought it hit those points then.
Now, does this start making sense?
Yeah.
It's a lot of
The second
algebra,
time- The second time better.
and you have to understand what everything represents.
I have to go back. 3.1.
So this is min and max.
So,
This is concavity. Now, why did I not set my second derivative equal to 0?
It can't equal 0.
because I can't, because if a concavity is 0, it's just like this.
So right here, no, let's take a look.
It can't.
Will this one work? Will my
Zero
second
does not equal
derivative?
8. 0 does not equal 8.
Yeah, 0 does not equal 8. For my second derivative, I cannot have that. So 0 will not equal 8 because I wash out the bottom.
So then to find the concavity, you could just plug in the x's for that. Instead
From your first derivative, your min and max. So that's going to tell me min and max here. So that means that's going to be a max for that, and that's going to be a min for that.
Okay. Hey, that was the first one.
Okay, are we okay on this?
0 equal 8.
All right, so let's take a look. So I think I am about out of time. So please don't forget, like and subscribe.